Alright, now let's do the perimeter for the circle class, and then we'll also do triangle and rectangle. Okay, the perimeter of a circle is even simpler. Well, actually, it's just as simple. It's not like it's any simpler. So the perimeter of a circle is just 2 times pi times the radius. Okay, or also pi times the diameter, same thing. So all we have to do is just say 2 times math.pi times 5, okay? And then here it's 2 times math.pi times 0. And for reference, I'm just rewriting these test cases to be to reflect the perimeter and not the area, okay? And then of course we'll have to change this to dot perimeter, and we'll also do a check to see if if changing the radius, or rather, we'll do a check to see, or a test that verifies that changing the radius actually does cause the perimeter to be recalculated. Okay, which it should. I mean, that shouldn't be a surprise. Okay, and of course, I mean these are going to fail because we haven't done anything yet, but we'll do that now. So it's 2 times math.pi times the radius, and all of these should pass, and indeed they do. Okay, very good. So now let's do the rectangle class, and we'll kind of breeze through this because this should not be very surprising. So we'll have a private double width, a private double height, and then a rectangle constructor that receives the width and height as instance variables. Very good. And then we will generate the methods to override. Very good. Now, if you want to very quickly generate getters and setters, here's a trick you can do. You can do Alt Insert on Windows, or just right-click Show Context Actions. Never mind, that's not how you do it. So, I don't know the shortcut on Mac OS. Sorry. On Windows, do Alt Insert. It might be with the Option key. I'm not sure. We're going to go to Getter and Setter. And then here, just select all of these. You can do that with Control plus the mouse click, or you can just press Control A. And then here, select IntelliJ Default. And then it will generate the getters and setters. Now, it will make these public unless you change this in the IntelliJ settings, but it's fine if they are public. Remember, there's not a big difference. I just don't strictly teach it until it's necessary because there's no need to. Okay, but that's how you get your getters and setters. But it's important to realize that it will use the same casing as the variable name itself. So if we were to write this instead, let's undo this. Rather, let's redo this, and we'll copy it for now. So if we were to change this to, let's say, height, let's misspell it just for the heck of it. So if you do this and then generate them, it's going to generate them misspelled, and it will also generate them wherever your mouse cursor is. So make sure that 1, the casing in the name is correct, 2, that your mouse cursor is where you want them to actually be located. Okay, so yeah, very good. So I mean, we could write tests. I will write tests, but I'll write them off camera, so I'll be back. Alright, tests are done. So all I did was I just took the tests from here, changed them up, instantiate a rectangle instead of a circle, and then put in the code for testing the perimeter and the area, and also changing the dimensions of the rectangle. Okay, so that's very straightforward. And the area of a rectangle, hopefully you know, is just the width times the height. Okay, the perimeter of a rectangle is just it's 2 times L plus 2 times W. But if you know anything about algebra, you can refactor that into 2 times the length times the, 2 times the length plus the width. Okay, so we'll do 2 times this dot width plus this dot height, and by length I mean length, width, height doesn't matter. Width is the horizontal, height is the vertical. Okay, so let's run this now, and everything should pass, and indeed it does. Okay, triangle is actually actually implementing everything is exactly the same as rectangle and circle. The only difference is that we're going to have three variables for the different sides, or the lengths of the three sides. Okay, so we'll create the constructor, and then we will instantiate the variables. Nothing by now. I mean, this is just getting a little monotonous here. And yes, there are much faster ways to do this, and in fact, there are ways to generate the constructor automatically. But I think at this point, you still need to get practice with actually writing out the constructor. Okay, but we will go ahead and generate the stubs for the two methods that we're going to write, and we'll also generate the getters and setters, because I think that those are very, very straightforward. It's just typing out the getter, returning the instance variable, and then typing out the setter and assigning it to the instance variable. You'll also notice that in the getters, they actually don't put this dot here, and that's fine. Again, there are ways to change that in IntelliJ, and I personally would. I just forgot to do it in this setup. But it doesn't matter. It doesn't for the setter, because there's a name confliction, right? So this parameter is the same name as the instance variable, so you have to put it here, but you don't have to put it inside of the accessor, because there's no conflict. Okay? So again, I'll write tests, and I'll be back when I'm done. Alright, so again, did the exact same thing as rectangle test, copy it, change up the numbers, and we're good. So one thing you do have to remember for triangles is that the sum of these two sides must be greater than the length of the third side, otherwise it's not a valid triangle. Okay, so just remember that, but we're not doing any kind of bounds checking, just because that would be, that would overcomplicate things. Okay, so but with that, we have the areas and the perimeters, and for this, because there's a slightly more complicated formula for computing the area of a triangle, if you're given the three sides, I just used a calculator online to figure out these values, and that's perfectly fine. Okay, but we'll do perimeter first, because the perimeter is very simple. It's just the sum of all three of the sides. So this dot side A plus this dot side B plus this dot side C. Okay, so we'll test that just to make sure, and everything's good. So the area of a triangle, if you're given all three sides, is actually broken up into two parts. You have to first compute the semi-area, which is just the sum of all three of the sides divided by 2. And if you know, you can get the sum of all three of the sides by just computing the perimeter. So it's the perimeter divided by 2, and then we will do return the square root. So this is actually a formula called Heron's formula. So here's how it works. You take the square root of, or let me make sure it's not the square root. Hold on. Okay, yeah, it is a square root. Okay, just wanted to make sure. So it's the semi-area times the semi-area, and since we're going to be using this multiple times, we'll just abbreviate it as SA. So it's SA times SA minus the first side times SA minus the second side times SA minus the third side. Okay, so if we do all that, our formula should be correct. It is not. Okay, so it looks like Heron's formula is slightly less accurate. So we'll just say as long as it's within, because that's actually a pretty significant difference. As long as it's within 1, then we'll be fine. Or actually, let's just change. Maybe the calculator that I used was incorrect. Let me verify the area of these three values. Okay, so the formula was correct. at least this first part was. I just forgot to add the decimals for some reason. So it is 2437, but the problem is if we have a delta as small as we did, then we're going to run into some precision errors. So yeah, and here I don't even know what I did there. I did it right here, but I didn't do it right here. Or no, this is right. I'm sorry. Yeah, I did the same thing here. So this should also be .212. So the thing here is that if we change the 3 sides, and then we check the area again, everything should be preserved. And, of course, all tests pass. Okay? So the only issue that I did there was that I just forgot the some of the decimals on the calculation. Okay? And that's something you can expect when you throw square roots into the mix. Okay? But the idea here is that we've created an interface that 3 classes implement, and they all override the methods differently. Okay? So they're all capable of computing an area and a perimeter, but they all do it differently. That's an idea known as polymorphism. Okay? And in the next video, I'll review this definition and we'll talk about another idea that's closely related.